All right, let's do a couple of problems from 11.4. Let's try 7. 7, 3 plus 6 plus 9 plus 12 plus 15. Sigma n equals 1, 1, 2, 3, 4, 5 terms. Love it. It's going up by 3 each time, so that's going to be arithmetic. Arithmetic means first term plus the difference, which is 3 times n minus 1. And I'm done with the first one. That's 7. Let's look at 9. 9's kind of twisted. 9's kind of twisted. 9 is 1 over 1 plus 1 over 4 plus 1 over 9 plus dot 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 1 over 100. Try arithmetic. Negative 3/4. Negative I don't know what, but certainly not right. Try this one. I'm multiplying by 1/4. Now multiply by 1/9. Doesn't really make much sense. So now look at the top and bottom is separate. And realize the top is always 1. The bottom is 1, 4, 9, and ends at 100. Huh. That's just squares, right? So it's 1 squared plus 2 squared plus 3 squared, dot, 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 10 squared. By the way, it tells us how many terms we have. So, sum is n equals 1 to 10. Top is always 1. Bottom is going to be n squared, and that's my number 9. All right, next one of interest to me is number 8. Number 8's nasty. Are we ready for number 8? No, not number 8. 8, 6 plus 24 plus 120 plus dot, 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 plus 40,320. So now I got to play the guessing game. How do I do this? Check it. I go 18 up. Next one's 96. That ain't it. Try the bottom. I got 4. Next one's 5. That one is interesting because A, it's not geometric, but B, it looks like I'm going up in a pattern that I might recognize. Now the problem with this is I only got 2 terms so far. How am I going to check? This is how I check. I would go, aha. So what if I multiply by 6? 6 times 120, I get 720. Let's try multiplying by 7. I get 5,040. Multiply by 8. And I get 40,320. Aha! So that is my pattern. Since it's going up by 1, it's a factorial. Crud. How do I deal with factorials again? Well, I know I need 4 factorial, followed by 5 factorial. So this first term is 4 factorial. Then I've got 5 factorial, then 6 factorial, then 7 factorial, then 8 factorial. That's in my run. So I'm going to go sigma n equals 1 to 1, 2, 3, 4, 5 terms. Since I've got n equals 1 to 5 terms, I've got to figure out how do I make it 4, 5, 6, 7. Well, that's just arithmetic, isn't it? And that just first term, which is 4, plus my common difference is 1, times n, drawing a blank, hold on, n minus 1, right, times, and then, sorry, and then so that would give me, when I put a 1, I get 0 for this, and I get 4, put in a 2, I get 1, I get 5, put in a 3, I get 2, times 1 is 2, plus 4 is 6, so I've got my right arithmetic, and then I got to tack on to the end, oh yeah, a factorial. Okay, so again, notice the factorial. I model the inside because it's arithmetic inside. Outside, I flap on a factorial. Which brings us to number 13. Let's see if we can figure out 13. 13 starts off as 16 plus 9 plus 20 thirds plus 5 1/2 plus 4 4/5. Now, if I didn't give you the hint, you should probably recognize I got a 3, a 4, and something I can easily make a 2, right? Or easily make a 4. So 3, 4, 5. So I might go, aha, 16 over 1 plus 18 over 2 plus 20 over 3 plus, this would be 11/2, so it would be 22/4 plus 24/5. Yeah? Now look at my pattern. You got 5 terms. I would go sigma n equals 1 to 5 of, what's happening at the bottom? Just n, right? When it's 1, when n equals 1, it's 1. When n equals 2, it's 2. What's the top? We're going up by 2 each time. Arithmetic. 16 plus n minus 1 times the common difference, which in this case is 2. And I've got my series. Fair enough? Fair enough. Okay, so that should hopefully get you through 11.4, and we should start 11.5 fairly soon.